In this video, we are going to talk about lemniscates and spirals. First we're going to talk about the equation for a lemniscate, which we did talk about on the discovery day, but it's going to be r squared equals a squared sine of 2 theta, or if we were doing in terms of cosine, it would be r squared equals a squared cosine of 2 theta. So when I'm looking at this first one, I want to remember that anytime I have sine, that's going to have my two loops at 45 degrees and at 225 degrees. Versus this cosine, their loops are always going to be at 0 degrees and 180 degrees. My length is always a, and so my a squared in this case is 16, so my length is going to be 4. So I'm going to put my length of 4, 1, 2, 3, 4 at 45 degrees and 4 at 225 degrees. Draw my two petals or loops, however you want to say that those look like, and that's what my lemniscate would look like. In this one, my a squared is 36, so my length is 6, and again my two loops are going to be at 0, 1, 2, 3, 4, and at 180, and so then I can draw in my two loops. Keep in mind that lemniscates will just always have two loops. The last shape in polar is a spiral, and that takes on this shape r equals a theta. So if we were going to graph r equals 2 theta, I'm going to make a little table of values. So if I put in 0, I would get 0. If I put in pi over 4, 2 times pi over 4 would be 1.57. 2 times pi over 2 would be 3.14. And then 4.17, 6.28, and then 7.85, 9.42, 11, and 12.56. So unfortunately, I'm only going to be able to fit up to here on my graph, but we'll kind of get an idea of what my spiral looks like. So let's plot these. So 0, 0, 1.57, 3.14, 4.17, 1, 2, 3, 4, 5, 6.28, and 1, 2, 3, 4, 5, 6, 7, and then a little extra. And so our spiral is going to look something like this. If we kept going off our graph, it would keep going around, something like that. So they are going to rotate counterclockwise. And the most important thing is just to understand what their equation looks like. It always looks like r equals a theta. It could also just be r equals theta if a is 1. 0.5. On the back here, we're going to write some equations. So the first thing we want to do when we're writing an equation is identify what type of graph we have. So based on the picture here, I can see that I have a rose. And so I know a rose can be written in terms of sine and cosine. So I want to look at the starting point. My starting point is at 0. If my starting point is at 0, that means I'm going to write the equation of the rose in terms of cosine. If it started at something other than 0, there was no petal there at 0, then it would be a sine equation. So the other thing I need to figure out is what is A and what is N. So remember, A is our petal length. So if I count 2, 4, if this is 6, that would be 5. And then N is, well, N could be two things. N could be the number of petals if it's an odd number, or N is half the petals if it's an even number. So I have 1, 2, 3, 4, 5, 6, 7, 8 petals. So in this case, my N is going to be 4 because we always double N when we have an even number. So my final equation will be 5 cosine of 4 theta. All right, in number 2, I have a line. It's kind of hard to see at first, but it's right here. And so this line is at y equals -4. But this would be a rectangular equation, and we're not writing a rectangular equation. I want to write a polar equation. So we know from our converting that y is the same as r sine theta. So r sine theta would equal -4. But when we are solving polars, we always want to get r alone. So I'm going to divide by sine theta. And so I'll get that my polar equation is r equals -4 over sine theta to represent that line. All right, in 3 and 4, we have to differentiate between a circle and a limacon. So if I look at this graph, I can see that it's 1, 2 to that side, and 1, 2, 3, 4 to the side. So it's not going to be a circle. A circle is either centered at the pole or is tangent to the pole. So this cannot be a circle, so it must be a limacon. And so that's going to follow the pattern of A plus or minus B, and then either sine or cosine. Since I can see that my symmetry is with the y-axis here, I know that this is going to be a sine theta. I also know that it's going to be, if I'm looking here, it's actually going to be negative because it's in the majority of the limacon is in the below the pole. So my equation is going to be r equals something minus something sine theta. So remember, your A is always your width. So here I can see my width is 3 and 3. So I know my A is 3. Then we know that A plus B will always be the longer length. So in this case, that is 4. And A minus B will always be the shorter length. So in this case, that's 2. So that means my B value must be 1 in order to write this equation. All right, so looking at number 4, I see that this is tangent to the pole. So that means it's a circle. And I can see that it's a 1, 2, 3, 4, 5, 6 diameter. And then it's actually going to be -6 because we are in the below the pole, so we're in the negative y. Speaking of being in the negative y, it'll also be sine since we're in the y part of the graph. So -6 sine means I'm going down 6 in the y direction to make the diameter of my circle.